As we speak, there are thousands of new hackers every day that are dedicated to breaking into devices and compromising sensitive data. This requires exhaustive analysis of our electronic devices to ensure security is upheld and we adapt to the drastically changing landscape. For this, Casper is pleased to introduce its next generation capability, SVX, to provide an automated solution for SOC security verification, powered by generative AI. SVX automates the pre-silicon design analysis of RTL, enabling the generation of security properties and the identification of potential vulnerabilities. By integrating seamlessly with existing property-based verification tools such as formal engines, SVX significantly streamlines the security verification process for engineers, delivering orders of magnitude reduction in verification effort and time. It is not a new verification approach, but a tune-up to your existing methods. This is critical to deliver as the semiconductor market suffers from tight time to market and efficiency problems. As design complexity increases, so does the verification work, and the current focus is on functional goals, leaving unaddressed areas where security vulnerabilities can arise. Organizations may already have internal databases of weaknesses, vulnerabilities, and threat models for security verification, but this is not exhaustive. Vulnerabilities are real that can arise from complex interactions of design and security landscape scenarios. This requires the use of exhaustive and comprehensive verification techniques alongside a deep database of security knowledge to weed out these concerns. A powerful approach is through formal verification. However, there is a stigma that formal is difficult, time consuming, and heavily reliant on user expertise, leaving it error prone. This is where Caspia Technologies' SVX solution comes in. SVX is an expert AI agent for your property verification flow to enable comprehensive and robust security verification. SVX fits into existing verification flows and tools to tune up your capabilities, not requiring anything new. SVX automates the generation of security properties and assertions and helps you fix security issues to ensure your design is free from these level of weaknesses. By leveraging recent advancements in generative AI, it alleviates the need for security subject matter expertise by automatically analyzing the provided design RTL for potential threats, identifying security assets, and generating a comprehensive suite of security properties and assertions. Now, let's step through how we can use SVX to identify and fix security issues. We will use, as an example benchmark, the Hackat DAC 2021 design. This is a RISC-V SoC made up of over 20 blocks of IP with over 100,000 lines of RTL code. Numerous security vulnerabilities have been included in this design, but we do not rely on this fact in our analysis. To demonstrate the power of SVX, we'll first demonstrate how we can identify security weaknesses with the current-day manual approach. We must start by mapping our verification checks to higher-level product specifications. Since security is often not a focus, verification planning can be ambiguous and dependent on deep expertise. We must then analyze design context to identify assets and correlate to relevant threat models, which will then help us define relevant security properties. We can then use verification tools to ensure the properties are met, such as mapping the security properties to assertions to run with formal engines. This will require expertise in formal verification to create high-quality assertions. Given this benchmark, we know communication ports increase observability and controllability, but threaten confidentiality and integrity. Therefore, we can take specific communication blocks, such as JTAG, to ensure certain security is met. We can produce properties and assertions related to the communication password checking process, which is an important security behavior that must be implemented correctly to enforce proper access control policies. When we have these checks, we can then run the assertions through a formal engine and review the results. For this example, we were able to find a property violation, and upon further analysis, can identify that the password success flag for the JTAG block has improper reset logic, leaving the opportunity for an unauthorized user to bypass the authorization state. This will give any user access to the JTAG communication network of the SoC, which is connected to sensitive bus traffic and overall chip control. This is just one example of stepping through the manual security verification process to identify a vulnerability. To more comprehensively ensure security behaviors are upheld and perform a larger scale vulnerability detection, you would require months of costly work. Now, let's see how seamlessly SVX can automate this process to give us the answers in just hours to minutes. SVX will use fine tuned large language models for textual information processing of the RTL, use its catalog of silicon attacks in the backend database with associated asset to threat linkage, and autosync with CWEs and other vulnerability information, as well as derive precise signal specific behavioral rules for the design under test. And finally, compile these into compliant system verilog assertions. This gives users without security knowledge the expertise to enable vulnerability identification. For users with certain security expertise, it will enable them to more efficiently go from a threat model and create high quality assertions. Now, let's step through the tool. We'll open Caspia's unified platform interface for our security verification tool suite. We'll create a project dedicated to our analysis and include our RTL design files. We will then select the corresponding IP family for our block. We will see auto-generated functionality information that describes a general spec for this. We can then run a SVX session. For the session setup, we will provide the general attacker capabilities that will help prompt our assertion generation. We can then run SVX. This backend analysis takes into consideration numerous factors to produce the properties and assertions. It is using the integrated and wealthy database of security knowledge, which is derived from hardware CWEs, years and years of research from Caspia Technologies team members in hardware security, including tens of textbooks and thousands of papers on the field, alongside novel GenAI learning paradigms and infrastructure elements for informational retrieval to use standard large language models to produce our results. It does not contain its own proprietary model. Instead, it uses open source models such as Mistral to deliver the capabilities, allowing for customer-specific LLMs to be integrated. Back to the tool. This took less than 15 minutes, and we can see our automatically identified assets and corresponding assertions. For each asset, we see explanations on the identification and the associated properties. We can modify this information and input our own if desired. For the generated assertions, we see the natural language property for the check, as well as the corresponding system verilog assertion. We also provide additional security context information to understand the importance of the check. With these generated, we can run these through industry standard formal engines from the big three EDA vendors, in which SVX integrates seamlessly to format the checks and help run the tools. When we run these assertions through, we can identify which ones hold and which ones fail. Within the set generated for this example, we see a failing assertion. And when we look at the associated security property, we can see how SVX has been able to identify the same vulnerability that we found and proved existed through the manual process. We have just reduced the security assessment from months to minutes. Not only will SVX identify the issues, but also help you fix them. By linking the assertions and properties to known security behaviors and identified assets, you can understand the importance of each violation and fix it with standard functional development practices, not requiring new engineers. SVX will also contain metric-driven feedback that will help provide quantifiable assessment. Please reach out to Caspia to learn more about the SVX roadmap. With SVX, we are able to identify security weaknesses that threaten the confidentiality, integrity, and availability of on-chip data. We drastically improve the security verification time and enable this for all users. We also produce high-quality assertions that are useful and solvable, minimizing false positives and noisy messages, and focusing on truly important security issues. SVX is there to bring GenAI to your existing design flow and ensure secure by design.